In today's video, I would like to introduce a very nice problem. Our goal, we are going to prove square root of 5 is a rational number. In the other word, square root of 5 not a rational number. Okay? So the hint that I'm trying to give to this problem, just you are going to use the absurd proof by supposing square root of 5 is a rational number. At the end of the term, we will find a contradiction. Okay? So I would be recommend to give a try to this problem pre getting to the solution. Go ahead, pause this video when you want to come back to see the full solution. By the way, don't forget to support us with your like and subscribe. Now let's go ahead jump into the solution. By the way of contradiction, suppose square root of 5 is a rational number a over b such that we have GCD of ab equals 1. In the other word, b not divide a. Also, we want this term must be reduced to the lowest fraction. Okay, for example, if you have 4 over 6 must be equals 2 over 3. Okay, that is GCD of these two terms equals 1. Okay, so now let's continue with our proof. I'm simply going to solve this equation by raising number 2 as a power on both sides. So I will get e square equals 5 is multiplied by b square. Okay, now I'm going to break this one into two cases. If e is even, if a is even, that means a square is even. That means the right hand side of this equation must be even as well. In the other word, b must be even. Since a different than b, otherwise we will have a over b equals 1. Since both numbers are even, that means GCD of these numbers must be superior or equal to 2. Okay? Which is contradiction. So we cannot have GCD of this number equal to 2 because we already, by assumption we already have GCD of this number equals 1, which is contradiction. That means this case is impossible. Let's move on to the next case. If a is an odd, if a is an odd, that means a will be written on this form 2n minus 1. Okay, you can write this one in two different forms. You can write it as 2n minus 1 or 2n plus 1. Okay, both are correct. Okay, since a is an odd, that means a square is an odd. That means the right hand side of this equation must be odd. Since 5 is an odd, and also b square must be odd. In the other word, b is odd. B is odd. If b is odd, b will be written on this form as well, 2n minus 1. So I prefer to write e and b on this form as odd numbers in order to get us to the such expression where we can create a contradiction. Okay, the next thing, I'm going to take this value and insert them into the original equation to see what's given us. So by doing that, I will have 2n minus 1 quinary square equals 5 times is multiplied by 2n minus 1 quinary square. Now the next thing, I'm going to move over only one term 2n minus 1 to the left hand side of this equation in order to get the difference of two squares. Okay, I will leave here 4 times is multiplied by this term. So I will get 2n minus 1 quinary square minus 2m minus 1 quinary square equals 4 times is multiplied by 2m minus 1 quinary square. This is the reason why I moved only one term, because I wanna build the difference of two squares where we can have a nice factorization. Okay, I'm going to factor this one out. I will get 2n minus 1 minus 2m minus 1 as a first term is multiplied by another term which is 2n minus 1 plus 2m minus 1 equals 4 times is multiplied by 2m minus 1 quinary square. Now I'm going to do some cancellation here. Number 1 will be cancelled out because one is negative, the other one is positive. And also I'm going to take number 2 out of this box from here for the second term. Also I will get 2n plus 2m minus 2. I'm going also to take number 2 out of these things. I will get 2 is multiplied by 2, which is 4. I get extracted number 2 out of here, and number 2 out of here. I will get 2 is multiplied by 2, which is 4. 4 is multiplied by n minus m factor n plus m minus 1. Okay, equals 4 times is multiplied by 2m minus 1 quinary square. Number 4 will be cancelled out from the left and the right. I will be ended with this expression. As you know, this is odd because it's written on the odd form, okay, like this. So to get odd, that means the left hand side of this equation must be odd as well. Since we have this product, that means this term odd, this one is odd because odd is multiplied by odd is always given as odd, okay. That means this one is odd. Also this one is odd. I will have two things. Since we have n plus m minus 1 is odd, that means n plus m is even. That means n plus m is even. And we have also n minus m is odd. If you take a look carefully at both terms, especially the second term, this one n minus m is odd. That's mean one of these terms must be odd, because you cannot have both terms odd, because odd minus odd is given as even. So we have odd. Since we have odd here, that's mean one of these terms is odd, because if n was odd, that's when this m must be even, because odd minus even is given as odd. Or inverse, if you have n is even, that's mean even minus I is given as always odd. That's mean only one term here must be odd, not both of them, okay. But here we have the sum of these numbers is even. Since one of these terms was odd, you cannot have even here. Since we have only one is odd, that's mean we must have odd here, because we have odd plus even is given as odd. That's mean this is contradiction, okay, because this one is telling us both numbers must be odd, which is contradiction, because you have only one number must be odd, okay. Since we found this contradiction, that means both cases are impossible to give us square root of 5 as a rational number. That means square root of 5 is a rational number, okay. Now I have done with this proof. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.